So the title of the presentation is Energy Efficiency in Smart Cities. And it comes through my work with ISO. So I've been working on this topic for so many years, boosting energy efficiency in buildings. I'm glad that the past presentation talked about sustainability and energy efficiency in buildings. So in here, this is the timeline of research and standardization for energy efficiency in buildings. You see that we start in the 1980s looking for the building envelope and the heating, probably. Then we turn into cooling, and then we have energy use for heating and production, heating and cooling, and then we have now buildings that are producing energy. So all the time we have to, or we're looking for the energy performance, energy utilization, energy use, energy needs. And since I'm from Egypt, originally born in Scotland, then I like pyramids. And we call this the energy pyramid, where we look at the energy performance, aggregates, and data. The question we ask ourselves all the time, because our goal is to provide fresh air, clean, at the minimum energy utilization to keep our lungs running with fresh and clean air. So the question we ask is, can we make a difference? And I think the answer is yes, we can make a difference. I'm sure you see this many places. So the wagon has square tires, and it is loaded with circular tires, which is very bad. Because we have to learn that the round wheels of today will be the square wheels of tomorrow. So we are advancing all the time, and what is good today, tomorrow will be obsolete. So this is a good example that these guys are pulling and pushing the car, while if they put the proper tires, the car will go, or the wagon will go faster. Anyway, so we have 2 books on the topic published already, and with the advancement of the technology, now we are using building information modeling, and this will be an integrated process that makes drawing and scheduling much easier than before. So in the sustainable cycle of design of energy efficient buildings, we start by this cycle which you call the BIM cycle, where we do analyze, documentation, fabrication, and then we go in. So instead of having Bob the builder, now we have BIM the builder. And I think it's worldwide. You cannot just do any consultation work if you only use AutoCAD. Now we move to Revit. And of course, it's one of the stages of the BIM. So for engineering education, all our graduates should be in command of the BIM, because it allows you to design buildings efficiently, to know the inventory for the cost, the maintenance, and so on. So here I'm trying to summarize the relation, because last September in Oslo, I'm the convener of the Energy Efficiency in Buildings Committee with ISO, and I was asked to do new standards that relates the energy efficiency and the BIM. So instead of having only energy efficient buildings relating into the standards that are available now, they are called the 52,000 series, I will be showing in a minute. Now we have to find a relation to make it easier for us to get building information modeling. So we are trying to do some work on the various aspects of SIM and also ISO on the BIM modeling of designs. So these are the various levels of the BIM, building information modeling. We can have it as simple, where we can do the design drawings, workshop drawings. Then we go to a further step when you do your calculation sheets, your cash flow, and so on, commissioning, etc. For every individual building and every individual equipment, we should have a label like this. And the label goes into 7 stages from A into F. And these are international. So when you are buying the building, you are looking for the BIM model for the building. It allows you also to do zero crash report, meaning if you have your plumbing pipes, we don't interfere with the ducts for the air conditioning or with the slab for the civil engineering. So it makes the coordination at a very early stage. You don't have to wait until you start construction where you find these problems. We always have to cross this bridge to satisfy the stakeholder by putting more standardization into the energy efficiency. So why does the energy use vary? They vary because of the building design, services design and performance, and very important, the occupant behavior. You will find the people in the Middle East different than the people in the US, different than the people in Europe in behavior. And the energy efficiency depends on all these. Here are some of the examples of the energy efficiency labeling, and it's still 7 stages. Here we have in different countries. You can see that different countries, but still all 7 grades. That's one net zero energy building that I commissioned in China years and years ago. You can see the facade is very important, as my colleague mentioned, very, very important. Of course, maybe from the architectural point of view, I'm a mechanic, I'm not architect, my wife is, will make a difference. But this shape makes more flexibility for the design. Now we look to our babies, the water heaters, the pipes, evacuated tube pipes, and also the photovoltaic cells. So these are now common practice in any building that you would like it to be energy efficient or net zero energy, the evacuated tube. Now, that's from the outside of the building, but what about inside the rooms? I want to air condition this room, heat or cool, and still my customer is sitting down watching TV, and air is coming from the ceiling. Which type of supply diffuser shall I use? Which one will give the best efficiency of air distribution? So we need to do some computational modeling. If you look for the various energy inputs, you'll see that you have inputs from the renewable energies at the top, primary source of energy, and this is what we have in the ISO 23045. Now, the balance of energy in the building, we have some passive systems that we'd love very much. We should maximize because they are free. Look into the fabrics, the building envelope, thermal mass, insulation, natural ventilation to maximize, and also natural lighting. Active systems that use carbon or use energy or use electricity, we'd like to minimize these. These are like heating, artificial light, ventilation, and cooling. Renewable energy is always welcomed all the time. So when you are doing a building, you have to look into these grades. One of them I like very much, which is the last one. And I always tell my students to concentrate on innovation and added values. Listen, when I was your age, and you are all much younger, nobody tried to blockade the way of thinking. So I'd like very much to encourage the young generation to innovate. We cannot put them in boxes and say, that's it. Days prove to us all that things are changing. And the square wheels of, the round wheels of today will be square wheels tomorrow. So we have to keep changing. Can you imagine the automated system with just Ethernet cabling and controlling all what's in our residences? This was non-existent 30 years ago. Now it is part of our promotion for new and smart buildings. And it will be more and more. So we have to accommodate, we have to prepare ourselves for this. Now, since I work with the ISO standards, so we started by first putting definitions. You cannot work without definitions and terminology. And it took us 10 years to put the definitions for the energy efficiency. Then, of course, we have the assessment of the overall energy performance. And in 2014, the committee that I chair was commissioned to start up the ISO 52000, which is all the series. We have 150 standards relating to all aspects of energy in building, energy efficiency, starting from heating system, cooling system, ventilation system, etc., etc. And we managed to finish these last year and early this year. So these are all in existence now, and I'm sure they are making our life much easier than before, because once you do work with modules like here, then you have the policy and you have the local national assessment protocol, because every individual nation will be different than the other. So we have a module, a main module, and then we have annexes for each country to do with. For example, how to implement the renewable energy from photovoltaic with the national grid and calculate all the energy performance in the seasons at various loads, 0 loads, 100% and 50% loads, and so on. We also started some new standards on the framework of the daily schedule, and this comes from Japan, Professor Shueda, and it tells you about human activity in buildings, which differ from one type of building to another and from one nation to another as well. So these are ISO standards now. Now the region we are in, this is the energy pattern, and you can see that we have geothermal, we have wind energy, hydropower, and also we have a massive amount of concentrated solar power. And we are not using it wisely. We have to. And high concentrated photovoltaics are, as my friend and colleague mentioned, is very important and very promising, because the photovoltaic cells now used to be 17% efficiency, something like that. But with this high concentration, they go to 40 and 40 plus. So there's a conceptual change here. You remember years and years ago, before we all were born, the auto cycle efficiency was about 13, 14%. Imagine now we have 50 plus, right? That's what I call conceptual change. It's 3 times. So we need that for solar energy and also for photovoltaic cells. So next, we cannot do or live without power generation. So we switch the lights. If we use conventional power plants, we produce carbon dioxide, carbon monoxide, nitric oxides, and also volatile organic compounds, and we have to reduce this. We need energy standards. To look at to the right is our systems, at what we like to have for electric appliances, lighting, cooking, cooling in the home. And also we have to the left our sources of power, and including, of course, the renewable energies as well. Again, the various energy labeling. I'm sorry this is in Arabic, but I meant it to keep it in Arabic. This is for Egypt, because to tell you that no matter where in the world, you have to abide by a unified system. And here we have the 7 grades. I was responsible for that in 2014. Of course, the industry, they hate me, because in 2017, we changed the values of the EAR. First, it was 8.59 EAR, and of course, everyone was happy. But worldwide, this goes to 15 and plus. So why not? So we made it into stages. 2014, 2017, and 2020, they will increase by 1 digit more again. And I'm just giving you an example of a developing country. Developing countries again, solar power plants. We have a 100 megawatt solar power plant under construction in the south of Egypt to get you 100 megawatt power. The cost is a very important factor, but also the more we apply renewable energies in our buildings and societies, the more it becomes cheaper. Here, for example, some of the buildings, this is in Morocco, where you have the windmills at the top, you have solar photovoltaic on the facade, and also you have water heaters at the bottom. So you have the three of them in one thing. Here you have some photovoltaic. I think this photo, everyone, this is my cat. And he always sits on my laptop like this. This is his asylum. When he's afraid of my kids, when they were kids, he comes there, nobody can touch him. And he appreciates my work a little bit. Now, this is a more recent. He was preparing for his PhD. Actually, my daughter got her PhD. And thank you very much for your patience. And if you have any questions, I'll be glad to answer. Usually they ask me, where are the hands? So yes, he has two hands. Thank you very much.